roller coaster. It's 300 kgs with passengers, accelerates down a very steep hill. Assume that friction is small enough that it can be ignored. Draw a force diagram for the system of the car and the riders. Okay, so friction is ignored. So here's my system. We only have force of gravity on the car and a normal force. And when I put those together, overall force is this way, total force, which is that's a 90 degrees, that's a 65. This is my normal force, and this is my force of gravity. Calculate the net force. I know the force of gravity is 300 kgs times by 9.8. So I've got 2940 newtons here, 65 degrees. This is the hypotenuse. This is the opposite. So SOHCAHTOA, sine 65 equals opposite, which is the total force, over 2940. Times by size by 2940, you get total force equals 2940 times sine 65. Calculator says 2665, rounded off newtons, but I'll keep it in my calculator so I can use the answer button for the next one. What's the acceleration? Total force over mass, which was 2665 newtons. What's the mass? 300 kgs. Divided by 300 equals 8.8 meters per second squared. If they're traveling at 4 meters a second at the time shown in the picture, so that's its initial speed, equals 4, how fast will they be traveling at the end of the stretch? And distance equals 20. We know acceleration, 8.8, and we want to know what final speed is. A formula that has all those in it is Vf squared equals Vi squared plus 2AD. So Vs squared equals 4 squared plus 2 times 8.8 times 20. So that equals plus 2 times answer times 20, 371, and that's Vf squared, so take the square root of both sides, gives us Vf of 19 meters per second. Two significant figures. 70 kg box pulled by 400 force, so this force here is 400 newtons. Angle of 30 degrees to the horizontal, the force of kinetic friction, so friction is 75 newtons. Draw a force diagram. So the force of gravity, it's kind of been pulled upwards a little bit, so it's the ground doesn't have to do as much work, so that normal force is smaller. There's a force up here, which is 400, and there's a backwards force of 75. So when we put these together, we've got this goes down, this goes up here, then the normal gets us up to where we need to be, and then the 75 is back a little bit, and there's some left over, from start to finish. There's some net force left over for us. And it's only in this horizontal direction. That's really all we care about. So we can redraw the bits we care about as kind of, we can make a triangle out of this, right? Why don't I make a triangle out of this? Work out the length of this. I'm going to call this side X. Once I get X, I can subtract my 75 and I'll get this net force. Yeah, because I've got this 400, I've got enough information, and this is 30 degrees here, so this is 60 degrees here. That seems right, doesn't it? Yeah. All right, so let's work out X. So if I was to do trig SOHCAHTOA, toa, hypotenuse opposite, sine 60 equals X over 400. X equals 400 times sine 60, 346 newtons. So that's that whole side there, but then minus the 75. Minus 75 equals 271. So my total force equals 271 newtons. Acceleration is total force over m equals 271 newtons over 70 kgs. Which equals 3.9 meters per second squared. Cool. I'll just quickly do the last question as well in this one video. Two lovers parked on a cliff, blah, blah, blah. Jealous suitor ties a rope. Ugh, evil person. Lowers the rock. The car, which is neutral, accelerates. This is modified Atwood's machine, right? Ignore friction. Draw force diagrams for the rock and the car. Okay. The rock has some force of tension up, but the force of gravity is bigger because it needs to accelerate. The car has a force of gravity and a force of normal which cancel out, and some tension force pulling it. Determine the acceleration of the car towards the edge. I don't know the tension force. What I might do is do a force diagram for the whole thing. This is a tough one. I mean, this is well past level 2. This is kind of university. This is the modified Atwood machine. When you have a pulley, and this has a pulley, so you've got the car, you've got a pulley, and you've got something else. A pulley just changes the direction of a force around a corner. So these forces, which I'm just redrawing these force diagrams here, you can redraw this and move this whole thing up here, rotate it around, so unwind the pulley, if that makes sense. And if you think of the whole system, what we end up having is when we've unwound the pulley, here's the car now on its side. These cancel out. It has a tension force that cancels out with the tension force on the rope, and all you're left with is the force of gravity on the rock. That's all you're left with. So if you look at the whole system as one, instead of an individual rock and a car, it becomes simple to work out the acceleration of the system, and the rock and the car accelerate at the same point. So the total force of the whole system is equal to the force of gravity on the rock. Right, so let's use that. So I said the total force is equal to the force of gravity on the rock, which equals, it's a 50 kg rock times 9.8 newtons per kg. So that equals 490 newtons. And when we work out acceleration, because we're looking at the acceleration of the whole system, 490 newtons divided by the mass of the whole system is 1050. Divided by 1050. That's a small acceleration, 0.46 meters per second squared. How long do the lovers have to apply the brakes before they go over the edge? So now we use this acceleration to work a kinematics problem or an equation of motion problem. So we want to find time. We have initial speed. I'm assuming it's parked up. Yeah, so it starts off at 0. We know the distance, 10 meters, and we've worked out the acceleration is 0.46. So things that have all those in it is d equals vit plus half at squared. Vi is 0, so you get d equals half at squared. Rearrange to find t, times 2 by both sides, divided by a square root. If you get to this point, you're doing extension problems, I can just try and do it in one go, but it's only because I've done this a bajillion times that I can. And that is 2 times 10 divided by 0.46, which is 20 divided by answer equals square root answer equals 6.5. And that's what we get down here. That's a tough question.